Let's try to solve this multiplication cryptarithm. A 4-digit number ABCD is multiplied by 4, and the result is also a 4-digit number DCBA. So the order of the digits is reversed in the product. We need to infer the values of these letters A, B, C, D. We need to infer what digits they represent. So just by looking at this multiplication operation and going over the steps, 4 times D results in a number whose units place is A and so on. It's not clear it's not obvious what values these letters take or what digits they represent. So as before, we will start by picking one of these 4 letters and enumerating all the possible values that it can take. And for all the values that it can take, we will try to find out if there are legal values that the other 3 letters can take. And if so, then we would have discovered at least one of the solutions to this cryptarithm. So what letter should we start with? So we can either start with an A or with a D. I would start with an A because if you notice, the product is constrained to be a 4-digit number. Now that means the value that this leading digit A can take over here is restricted. For example, if A was equal to 3, that is, if this number was 3000 something, then by multiplying it with 4, we would get a product that was at least 12,000. And if the product was at least 12,000, then it should have had at least 5 digits, not 4. So A, the letter A, cannot represent a digit that's greater than or equal to 3, because the product is constrained to be a 4-digit number. And if A was chosen to be a digit greater than or equal to 3, then the product would have at least 5 digits. So the possible values that A can take would be 0, 1 and 2. In fact, A cannot be a 0 either because we cannot have leading zeros in our numbers. So A can either be 1 or A can be 2. These are the only 2 possible values for A at this stage. Let's take A as 1. If A was equal to 1, then we can rewrite this cryptarithm as 1BCD times 4 is DCB1. Now, is it possible that 4, when multiplied with a D, with some digit D, results in a number with 1 in the units place? If you think about it, that's not possible. 4 times any number at the minimum must be an even number, and 1 is an odd number, or any number ending with a 1 is an odd number. So we cannot multiply 4 with any digit and end up with a result that has a 1 in the units place. So in fact, there are no possible legal assignments of digits for these letters B, C and D, because this operation is legally not possible. It is impossible to have a 1 in the units place when this number is being multiplied by 4. So this route leads nowhere. So A cannot be equal to 1. So A must be equal to 2. So let's rewrite this cryptarithms with A replaced by 2. 2BCD times 4 is DCB2. Now from this, let's see if we can try to infer the possible values that D can take. 4 times D is some number that has a 2 in the units place. So what are the multiples of 4 that have a 2 in the units place? What are the multiples of 4? What are the single digit multiples of 4 that have a 2 that yield a 2 in the units place when 4 is multiplied by that number? Can D be a 1? 4 times 1 would be a 4, not a 2. So D can't be a 1. Can D be a 0? No, D can't be a 0 because 4 times 0 would also be a 0, not a 2. Can D be equal to 2? 4 times 2 would be 8, not a 2. So D can't be a 2. Can D be a 3? 4 times 3 would be 12, and we would write 12 by having a 2 in the units place and carrying forward a 1. So D can be equal to 3. So D equal to 3 is one possibility. Can D be equal to 4? No, because 4 times 4 is 16, and 16 does not have a 2 in the units place. So D can't be a 4. Can D be a 5? Well, 4 times 5 would be 20, which would have a 0 in the units place. So D can't be a 5. Can D be a 6? 4 times 6 would be 24, and 24 would have a 4 in the units place, not a 2. So D can't be a 6. Can D be a 7? 4 times 7 is 28. 28 would have an 8 in the units place, not a 2. So D can't be 7. Can D be an 8? Yes, D can be an 8 because 4 times 8 is 32, and we would write 32 by writing a 2 in the units place and carrying forward a 3 into the next column. So D can be a 3, D can also be an 8. Can D be a 9? 4 times 9 would be 36, and we would write 36 by having a 6 in the units place, not a 2. So D can't be a 9. So D can only take two possible values, 3 and 8. Let's look at both these possibilities. So either we have 2BC3 being multiplied by 4 and yielding a result of 3CB2, or we can have D equal to 8. So we would have 2BC8 being multiplied by 4 yielding a product of 8CB2. Now if you look at the first possibility where D is equal to 3, you'll find that this doesn't make any sense because you have a number that's at least 2000, that's greater than 2000, being multiplied by 4, and the result of the multiplication is a number slightly more than 3000. It's less than 4000. How can a number that's greater than 2000 when multiplied by 4 yield a number that's 3000 something? It needs to be at least 8000. So this leads nowhere. So D cannot actually be equal to 3. It doesn't lead us to any valid solution. So D must be equal to 8. So A must be equal to 2, D must be equal to 8. We have two values ascertained for sure. So let's move ahead with this possibility. 2BC8 times 4 is 8CB2. Now looking at this encoding, we can actually impose a limit on the possible values that B can take. Because let's say B was equal to 5. That means this number would be 2500 something. 2500 something when multiplied by 4 would be at least 10,000. So b can't be equal to 5. In fact, b can't be greater than 5. In fact, even if b was equal to 3, we would have a number that's at least 2300 being multiplied by 4. And even if you take 2300 itself, if you multiply that by 4, you get 9200. We know that the thousands place has an 8, whereas if we put b equal to 3, the product should at least be 9200. So this means b can't be 3. B can't be 3, and b can't be any number greater than 3, because as we increase the value of b, the product's value is going to increase even more. So that means b can either be a 0 or a 1 or a 2. In fact, b cannot even be equal to 2 because we already put a as equal to 2. So even this option is eliminated. So let's work with these two possible values for b. Suppose we go with b equal to 0. Then substituting b equal to 0, we get 20c8 times 4 is 8c02. Let's see if we can get a legal value for c over here. 4 8s are 32. So we have a carry of 3 over here and a 2 in the units place over here. Now 4 times this digit c plus a 3 should yield a 0. In fact, this can never happen, because if I multiply 4 with any of the digits from 1 to 9, I'm saying 1 to 9 because we cannot put c equal to 0 since b is also equal to 0. In fact, we cannot put c equal to 2 either. But if we enumerate all possible values of c and we add 3 to the result, we can never get a number with a 0 in the units place, because this number with a 0 in the units place would be an even number. This number is an even number. This number is an odd number. 4 times c must be even, and an even number added to an odd number cannot be an even number. An even number plus an odd number must be an odd number. So this is one way to reason that we can never get a legal value for c here, but another way to do it is you can just substitute different possible values for c from c could be either 1 or c could be 3, 4, 5, 6, 7, 8 or 9, and for each of those values of c you will find that when you multiply that value by 4 and add a 3, you never get a 0 in the units place. So this route does not lead us anywhere either. So b cannot be equal to 0. So the only possible value for b is 1. So we have obtained a is equal to 2, d is equal to 8, b is equal to 1. Let's see if we can get a legal value for c now. 21c8 multiplied by 4 produces 8c12. Now 4 times 8 is 32, so we have a 3 as the carry and a 2 in the units place over here. Now 4 times c, whatever that c is, when added to a 3, produces a number that has a 1 in the units place. So if we have a number that has a 1 in the units place being produced, so let's say we have a number with a 1 in the units place, and let's say I don't tell you what the other numbers are, we don't know what the other numbers are, being produced by adding a 3 to 4 times C. 4 times C plus 3 produces a number that has a 1 in the units place. This means that 4 times C must be a number that has an 8 in the units place, because if it had an 8 in the units place, then when we add a 3 to it, we would get a 1 in the units place. So which multiple of 4 in the multiplication table has an 8 in the units place? Well, 4 times 7 is 28. So let's try putting C equal to 7. In fact, that's the only multiple of 4 that has an 8 in the units place. Well, there's also 2. 4 times 2 is 8. So let's try putting both 2 and 8 over here. So let's say we put C equal to 2. Actually, C equal to 2 is not possible because we already put A equal to 2. So we don't even need to test that case. So we don't even need to test the case when C is equal to 2. So let's just straight away put C equal to 7. If we put C equal to 7, we get 2178 times 4. And let's say, let's do this multiplication and see if we get the result 8712. 4 8s are 32. 4 7s are 28 plus 1 is 31. 4 1s are 4 plus 3 is 7 and 4 2s are 8. In fact, we got a matching answer here, because if C was equal to 7, then we should have got an 8712 in the result, and that is exactly what we get. So this is the only solution to the given cryptarithms. ABCD times 4 is DCBA. You can see that A is 2, B is 1, C is 7, D is 8, and when multiplied with 4, the digits get reversed. 8712 appears in the result.